Hello, everyone, and welcome to today's MIT Startup Exchange workshop on computer vision and robotics. I'm Ariadna Rodenstein with MIT Startup Exchange, and we're very excited to bring to you the lineup of speakers that we have today. 4 startups on manufacturing and 4 startups on industrial and technology. In addition, we'll also have a panel with ILP members, startups, and moderated by Sheri Brodeur, ILP Program Director, and they will have a discussion on opportunities and challenges in these fields, and also how to make progress and work together with corporate partnerships. I will give a brief overview of MIT Startup Exchange, and then we will start with the lightning talks of the startups. Right after the program, we will go into a Zoom meeting for breakout rooms with the 8 startups, and I hope you will join us for that as well. And hopefully you can have some further conversations to see if there's a fit for future collaboration. We will post the link in the chat at the end of the event, but also you should have received it as an ILP member in an email. Again, this workshop, as well as the breakout rooms, are a great benefit of being an ILP member. In addition, I just wanted to give a couple other reminders. This event is being recorded, and also we ask that you use the Q&A box at the bottom of your screen to post questions for the speakers and also upvote questions. Again, please use the Q&A box, not the chat box. And now on to the mission of MIT Startup Exchange. So our program was created about 6 years ago within MIT Corporate Relations to help promote partnerships between over 1,900 MIT connected startups and over 230 ILP members. These are global 1,000 corporations covering all geographies and all industries. And here you can see some of the successful partnerships that we've seen throughout the years. Next slide, please. These are some of the trending technologies, and we will cover some of these today. For example, AI, autonomy, and robotics. Next slide. And finally, how can you engage with startups being an ILP member? One way is to join us at events like today's, or some of the other ones that are coming up in March and April. You can check the websites for that. You also have access to annual introductions by ILP program directors. You also have access to SPEX25, which is our accelerator group with industry-ready startups. We unveiled the latest cohort in November, and some of those startups are presenting to you today. And finally, you can post an opportunity. These are challenges for the startups. They can apply, and if you see a good fit, they can actually work with you to help you solve some of the problems you face in your industry. So with all that, thank you again for joining us wherever you may be today. And let's start with the first startup lightning talk. Eduardo Torrealba from Meter.
All right, my name is Eduardo Torrealba. I'm the co-founder and CEO here at Meter. I was fortunate enough to start Meter alongside a group of phenomenal engineers and entrepreneurs, many of whom graduated from the Institute over the years. And it's really been a pleasure to be able to be involved with so many of the great things that are happening here at and around MIT. Our team really got our start working for several years in the worlds of CAD tools and 3D printing and additive manufacturing. And we've seen firsthand this explosion in modern manufacturing complexity. Because of the tools that people on our team built, it's become easier than ever to build everything from additively manufactured parts to composites to batteries, both in design and manufacturing. But making something is really only the first step in the process to getting a product in the hands of customers and users. And quality is one of those things that really gates the ability to ship these products. And even though there's been this explosion in new tools and methods to make complex objects, the methods that you would use to inspect those things have really not changed in 20 or 30 years. So if you're a quality engineer or a manufacturing expert today, you have the same options of coordinate measuring machines, industrial CT scanners, or 3D scanners, to check the quality of the items that you're producing. And many of these methods might take a bunch of manual effort. They might be incredibly expensive, or maybe they take tens of hours of programming to set up a fixture jig and a program to be able to really understand the quality of the part that you've produced. And this all is just much more difficult than it needs to be today. And so what our team has done is we've built out a 10 times less expensive volumetric imaging system. This includes hardware that is essentially able to replicate the same performance as a conventional computed tomography scanner at less than 1/10 of the cost. thanks to a lot of the fundamental technology that we've developed internally, as well as a suite of cloud-based software tools that we've built from scratch to rethink the way that you interact with and distribute the data that you're able to create using these tools. As a quick example of the kind of thing that our technology is capable of, this is an alternator housing that I bought at an auto parts store here in Cambridge and then scanned in our system. We're able to get a very high quality three-dimensional mesh out of the scan. And then we can start doing things like looking at the internal slices, just like if you were to cut the part apart in the real world, we can look at the inside of that. And we can start to see things like voids and pores and casting defects and issues that would otherwise be invisible if you didn't have this kind of tool. And that's great, the sort of qualitative information, but we've taken that one step further and we built out a suite of quantitative tools that really allow engineers and quality experts to start applying some more modern techniques to inspection than what they've had access to before. So here we give you a three-dimensional visualization of every pore inside of this part, as well as quantitative information that you can export and do statistical analysis on to really understand the progression of an object that's being produced, the health of the manufacturing line, and spot problems before they become catastrophic and lead to failures or recalls or massive amounts of waste in the manufacturing environment. We have a number of other applications that we've been developing. So everything from CAD comparison, reverse engineering applications, critical feature inspection. You can think of it as like a digital check gauge, as well as porosity detection and analysis, like I just talked about. We've even built out the tools to make it possible to do really high quality digital twins off of the data that our machine produces. So today we're working with companies across a number of different sectors, everything from automotive to aerospace, batteries, power tools, heavy equipment, you name it, we've probably stuck it in our scanner at some point. And we would love to talk to anybody out there who's interested in making physical products and finding ways to make that more efficient. So if that's you, please join me in a breakout room at the end of the session today, or feel free to shoot me an email, a text message, call me, or follow me on Twitter. I'm pretty easy to find out there. So thanks so much, and hope to connect to you soon.
Great, thank you, Eduardo. A question from the audience. Can you expand a little more about your hardware/software platform?
Yeah, so our hardware platform, we have a physical device that we've developed. We're installing the first unit at a customer's facility here in Boston very soon. Our software platform is live today. We're working with customers who are sending us parts, we're scanning them and giving them access to the data set. So if you're interested in it, I'd love to give you a demo and find a way to work together on that.
Thank you.
Thank you
so much. Moving on now to Eureka.
Right, my name is Cuong. I'm a co-founder of Eureka Robotics. At Eureka Robotics, we are enabling high accuracy, high agility automation. So there already exists robotic solution to automate tasks with high accuracy, but at the expense of agility. Think of robots in car manufacturing lines that assemble components with high accuracy, but which takes so much time to reprogram to a new car model. So that's high accuracy, low agility. On the other hand, there exists also robotic solution to automate tasks with high agility, but at the expense of accuracy. Think of warehouse robots that can pick different types of objects, but which have accuracies of several millimeters at best. So this is low accuracy, high agility. Until today, tasks that require at the same time high accuracy and high agility, in other words, HAHA, have mostly been done manually. For example, the task of picking tiny lenses that are randomly placed is high agility, and placing them into a fixture with sub-millimeter accuracy is a high accuracy part, is a HAHA task. HAHA tasks are pervasive in precision manufacturing, from optics to electronics to automotive. In fact, if a task is still done manually today, most likely it's because it's HAHA. Now, I'd like to ask you to think of a task in your industry that's still done manually. Okay, did you find it? Now, let's take 5 seconds here to think whether this task, which is being done manually, is a high accuracy and high agility task. Right, I bet it is. So how do we solve that? So at Eureka Robotics, we have developed a software platform to address HAHA tasks. It combines vision, so to locate, for example, random objects with sub-millimeter accuracy. Second element is a sense of touch. We can mimic the human sense of touch to perform insertion or assembly with micron level accuracy. Third, online motion planning and execution for the robot to adapt to the changing task parameters. Using our software platform, integration engineers can solve incredibly difficult HAHA tasks in just 30 days, which is 10 times faster than existing technology. So let's have a look here at one of our robots that's, as we are speaking, it's running in the factories. So typically here, the source is 1,000 lenses randomly packed, cluttered in a basket. Here you can see it's completely random and it's packed. The destination is a jig that has 0.2 millimeter clearance for the hole. And the cycle time you can achieve, this is real time, it's 4-second cycle time, 900 UPH. And the lead time to do this, we have developed that in just 30 days, which is 10 times faster than incumbent. So as we are speaking, it's the lenses are being picked, thousands of them in factories around the world today. So we deploy our software through partnerships with global robot manufacturers and third-party integrators. So I think I'm at the end of my presentation. Basically, we would like to, if you are a precision manufacturing company, we'd love to hear our HAHA challenges and see how we can help you address them. If you are a robot or a component manufacturer, we wish to partner with you for the development and commercialization of HAHA technologies. I would love to take the discussion further in the breakout session. You can also send me an email or visit our webpage. We are present in the USA, in Europe, Japan, China, Singapore. So very happy to talk with you further. Thank you very much.
Thank you, Cuong. Great. And a question for you. Can you tell us a little more about how Eureka is a little more unique than other startups?
Well, to our knowledge, very few companies, if not known company other than us, can solve high accuracy and high agility challenges, automation. And we can do that, and we have deployed robots that do that in the factories. And we can deploy those solutions extremely quickly in 30 days to 45 days typically, thanks to our software platform.
Fantastic, thank you. Now we're moving on to Tom from RealTime Robotics.
Great, well, thank you very much, guys. My name is Tom Munger, and I am the Director of Sales at RealTime Robotics. RealTime is based in Boston, and we're delighted to say that two of our founders have degrees from MIT, and we enjoy strong connections with the MIT community. RealTime's technology provides value to any robot working in any environment. However, today we currently focus on factory automation and autonomous vehicles. Today we'll focus our discussion around our factory automation segment. RealTime Robotics has created a proprietary and first of its kind combination of hardware, software, and robust spatial perception to enable robots and advanced robotic solutions to operate collision-free in dynamic and unstructured environments. RealTime Robotics is uniquely positioned in the market to bring a game-changing functionality to the manufacturing industry, which is the ability to deploy industrial robotic systems alongside humans, taking advantage of the best that both have to offer. Our motion planning product, the RealTime controller, which you'll see on the screen, provides 6 degrees of freedom robotic arms with the ability to quickly plan and replan optimal motions in real time. We often liken this to adding GPS capability or functionality for robots. Now, this functionality alone drastically reduces engineering time and complexity, and we sell this today as a standalone product. When combined with our complementary product, which is known as Rapid Sense, the solution can dynamically monitor the work cell and inform our motion planning platform of any dynamic intrusions in the cell. Now, depending on the situation, the real-time technology will either provide a new motion plan or simply stop the robot until a new path becomes available. Again, this is all in real time. As shown in the video above, when both products are used in tandem, the results are quite powerful. Rapid Sense uses 3D cameras, which in this case are mounted above the work cell, to provide real-time vision. The 3D cameras create a point cloud of the data informing the real-time controller which areas are occupied and which areas are unoccupied, almost like dynamic interference zones. As a result, optimal motions are selected at runtime in order to maximize key application parameters while keeping the entire cell collision-free. Now, RapidSense is ready to go out of the box. We have some really unique features. We support up to 10 3D cameras to eliminate any occlusions in the cell. We also have built-in automatic calibration and robot self-filtering. And in the future, we will introduce features like occlusion detection and optimization techniques. Now, real-time robotics operates in the sphere of dynamic robot control. By combining powerful motion planning technology with the advanced vision, we add significant value in essentially all verticals of robot deployments. In the structured application space, we shorten the time it takes to deploy complex systems like welding cells by introducing a streamlined way to program robot motions and eliminating the potential of collisions. As we add our vision products to the equation, customers enjoy the ability to take the dynamic scene into account. Real-time robotics is moving quickly toward the holy grail of robotics, something that most manufacturers and OEMs have been waiting for quite some time, which is the ability to apply a safety certified suite of third-party technologies to any robot, any application, without sacrificing overall production. And in fact, we drastically improve overall production. Now, the recent advancement of collaborative robots, or as you see on the screen here, power-enforced limited robots, has served a very important purpose. And it's widely accepted for many low-cost material handling type applications. Now, RealTime is poised to take that premise and advance it to the next level. You see, the challenge that power-enforced limited robots present is the nature of how they obtain that collaborative status. The robots must move at much slower speeds because essentially collisions are allowed. They move much slower than the typical industrial robotic arm, which therefore limits important specifications like payload and reach. Now, real-time robotics is taking the notion of collaborative and applying that to the entire system by leveraging our game-changing robot motion control and vision capability. These two things are used in tandem. And once safety certified, this will be a unique solution that uses both two-dimensional and three-dimensional sensors to allow robots to keep moving when people are safely in the same proximity of the robots. Now, customers will be able to deploy more robots in tighter spaces, maximizing throughput, and of course, decreasing floor space. So I hope you guys will join me in the breakout sessions a bit later. We would welcome introductions to global manufacturers and systems integrators, focused in the automotive, the electronics, and the e-commerce and logistics markets. Thank you very much for your time.
Thank you, Tom. A question for you. So you're working on technology that it's eventually, as you said, for human and robot collaboration. What other areas can your technology be applied to today, even without the pending safety certifications? Yeah,
that's a great question. You know, the holy grail is we want to be able to take motion planning and vision and combine that to allow end users to deploy robots safely around humans. But realistically, if you think about it, the robust spatial pipeline that we've built can be modified and applied to any dynamic scene. In fact, we do a whole lot of work in we call it the MH&L, material handling and logistics space, for things like mixed case palletizing, where there's a great deal of variability. For example, RapidSense can monitor a pallet as it's being built in a very complex and variable environment and inform the user or the system if a pallet build doesn't match the entire kind of prescribed build plan. Any situation where there's dynamic intrusions or dynamic considerations in a given cell, the combination of our motion planning and spatial perception technologies can be leveraged.
Perfect. Thank you for the clarification. Now we go to Kartik from Akasha.
Hello, everyone. I'm CEO of Akasha Imaging, and along with my co-founders, Achyuta and Ramesh from MIT Media Lab, our startup is focused on deep imaging to enable sub-millimeter pose estimation for assembly automation in manufacturing and other applications. So, the problem we are trying to solve is one of teaching robots to see in unstructured environments. Robots, as many of the other startups have already mentioned, find it difficult to work in such environments or to respond to unexpected events in today's technology. They work best when the environment is carefully structured for them. In most cases, every task is carefully sequenced and programmed and the environment is fixed so robots don't have to see. For example, 85% of the robots sold in industrial automation today do not have a camera associated with it or do not have any vision system. And it's not because vision is not needed, but it's because cameras do not work well enough in such unstructured environments. Similarly, in consumer packaging, from what our customer tell us, the rapid changes to goods produced either in the materials or the supply chain inhibit efficient automation due to high error rates when you have changing supplies. And finally, the unpredictable nature of environments at home or office locations limit automation due to the inability of the robots to see and learn from the changes that happen almost regularly. Our solution effectively leverages multimodal, multispectral, and multi-view geometry. On the left, we show a scan of a coffee cup using a Microsoft Kinect. This was a time-of-flight system, a fairly coarse resolution scan. The image to the right show the images captured with a camera using different spectral filters. By leveraging the relationship between the reflected light and the incoming incident light, we are able to build a very high resolution surface profile of the object as shown in the third image. This can then be integrated over the coarse depth map from the Kinect to provide a very high resolution refined depth map to the right. The features that you see on the coffee cup are about 100 microns deep, and they were captured at a distance of 2 meters with a conventional camera, off-the-shelf camera, just using some filters. The coarse depth map can come from any modality. It doesn't have to be time of flight or active illumination. It can be stereo as well. And we actually show an example in the next slide. So here what we have is an example of an application showing robotic interaction with our vision solution. So we have, we have this robot that is actually picking up the objects in the bin, transparent objects, which are actually very difficult for most vision systems to see well or scan well. And we have our stereo-based vision system in the tripod mounted above. The view as seen by that is shown in the lower left green window. And there's also a conventional camera in the tripod, and the view as seen by that conventional camera is shown in the yellow window to its right. And for the robot to be able to pick up things accurately and precisely, you need segmentation of these objects and localization in 3D so that these things can be picked up robustly and efficiently. And as you can see from the segmentation that is visualized in the lower left green window, it's always robust with our solution compared to the yellow left window to the right, where many of the times the objects are not seen, and even when they are seen, the boundaries are not very clear. There's an adversarial example to the left of the bin where you have a piece of paper with a couple of objects printed on it. And this is the exactly the kind of spoofing that can fool existing solutions. And as you can see in the yellow window, those objects that are printed are actually seen as real objects, but not so in our solution to the green window to the left. So the product that we are building is a vision and perception software coupled with custom hardware with a robot agnostic API. We work with all robotic systems. All of the compute for the robot runs on the edge, where we provide very high precision 6-stop pose estimation of the parts in the scene that enables the robot to operate with high accuracy, cycle time, and a reliability of greater than 99%. We also provide a connection to the cloud so that when errors do happen on occasion, we upload the images, the CAD models, and metrics to the cloud to re-enable training of the network models. The improved models can then be pushed back onto the edge to enable a process of continuous improvement. Furthermore, the assessment of these errors through a growing database of parts and materials use cases and failure modes gives us a significant data advantage over time, from which we can run all kinds of analytics that can expose all kinds of correlations for the customer. To summarize, our solution provides an order of magnitude improvement in localization precision over incumbent technology while operating in unstructured environments with any material, no active illumination of any kind. In addition, our extremely high reliability at 99% goes a long way towards reducing cost over existing vision systems and provides for a very viable automation solution. We are calling for partnership with companies that have needs in automating assembly, packaging operations in all sectors of the market, welding, automotive, electronics, packaging. We are currently engaged with customers in the automotive industry as well as the food and packaging industry, and we are going to be in deployment in the second half of the year on their product lines. And that concludes my presentation. Thank you all and look forward to meeting in the breakout rooms.
Thank you, Kartik. Great. A question for you. Would you present this more of as an imaging system or an end-to-end solution?
It is an end-to-end system because we have partnerships in the ecosystem, both robot manufacturers and other robotic companies. So we are presenting this as an end-to-end solution.
Thank you. And now onto the panel.
Good morning, everyone. First, I hope you and your families are all safe and well in these improving times. Happy to say that. I'm Sheri Brodeur, Program Director here at MIT Corporate Relations, which houses both the MIT Industrial Liaison Program and MIT Startup Exchange. Our mission here is to help connect our member companies into this incredible MIT, incredible and dynamic MIT innovation ecosystem. This includes both the academic world here at MIT, with opportunities for members to engage in both helping us educate our students and taking advantage of the wealth of programs here that help that will help upskill your workforce, and we'll talk about that some today. We also help you engage here in the research engine. About 750 million MIT is invested at MIT every year, and about $1 billion at MIT Managed Lincoln Labs. And last but certainly not least is to help our members engage with the dynamic MIT global startup community, which we have about 1,900 MIT connected startups as part of Startup Exchange. So after that introduction, let's get into the panel. The panel today will explore the challenges and opportunities in robotics and computer vision and how corporations and startups are working together to accelerate progress. I encourage you to ask questions early and often. I will be monitoring the Q&A. I have also encouraged the panel to ask each other questions because they're really the experts here, not me. So I encourage that very much. And so let's get started. Instead of me introducing the panelists, I'm going to ask them to do a short introduction, starting with the industry members, and then ask each of the industry members, industry panelists, to give an overview of what they see as the major challenges and opportunities in their industry in respect to computer, robotics and computer vision. So Jaap, let's start with you.
Hi, Sheri, good to see you. And the fact that I'm here listed as an expert on an MIT panel, I feel like the imposter syndrome is in full swing, fully dialed up in my face. But I think it's good to have people like us on here because at the end of the day, we're going to be consumers of some of the products and some of the technologies and some of the fantastic things that I think we've just seen presented by some of these entrepreneurs that work way harder than I do. But just to summarize, I work for FM Global, which is a commercial property risk insurance company. We're a mutual organization, so we're owned by our policyholders. And in fact, MIT is one of the businesses that we insure. And so is Disney, for instance. So it gives you some idea of the complexity of what we do. We're monoline. We don't do car insurance, health insurance. We do these big industrial properties, 1 out of 3 of the Fortune 1000. We're a mutual organization, but the main mindset that we have is that resiliency is a choice and that the majority of losses are preventable. So when I think, and I'll get directly, my role is part of FM Global's innovation team. Before that, I was a research scientist looking at fire hazards and protection, explosions, all that kind of fun stuff. But quickly switching to computer vision and robotics, I think for an insurance company like us, there's both a threat and an opportunity, right? So if we insure warehouses and they're now being controlled by robots, well, these robots are going to have lithium-ion batteries. So these are potential ignition sources. They can collide. The whole nature of what we call fire loading and what's in those buildings has changed. So we really have to have a very good understanding of how that's impacting the risk that we underwrite, just for reasons that should make sense. On the opportunity, which is more exciting for me as an engineer, mechanical engineer and aerospace engineer, is what is the opportunity? So we're doing a lot of inspections inside confined spaces. What kind of robots are out there that can do that for us so we can keep our people out of harm and keep the client out of harm, and similarly on roofs. And also with computer vision, what can we do to automatically process satellite imagery, fixed wing imagery, drone imagery, or even looking inside warehouses now and automatically detecting fires and smoke and those kind of things. So you think insurance company is kind of boring, but we're very engineering focused, and we love our relationship with MIT and ILP. And just so excited to be here today.
Thank you, Jaap. Yeah, but I found it fascinating that when I started, I work with FM Global in my role here, and found it fascinating they call themselves a loss prevention company. So it's very engineering intensive. I have not yet been able to visit your facility down in Rhode Island where you actually cause explosions and fires and things like that. But I see many opportunities for you with robotics and computer vision. So with that, Chris, are you here? I don't see your face, but I'm thinking you're here. Chris Campbell?
Yeah, so I'm Chris Campbell. I work for Michelin, and I'm part of the Industrie 4.0 program that's in our manufacturing sector. And this includes all aspects, including digital manufacturing and how we're managing data, to robotics, to flow automation, to make a complete industrial transformation in our company. And so I lead platforms in the Americas zone associated with robotics and flow automation. And we use vision in many of these applications to manage the complexities of the use case. And so as of today, we have over $300 million in identified opportunities just in our zone, not just worldwide. So we have no shortage in opportunity. The challenges are, as many of the startups have already identified, are around the relationship between human and robot, how we manage the safety, and then the business justification of doing those things. There's many times we find challenges in the last 10% of what we're doing for a case that may be hard to automate or use robotics or vision to do so, and the technology may either not be there or we just find challenges in what's there today as far as experience of the areas that we're looking at. And so we're also looking at how to develop these competencies internally. This isn't, technology, especially as it evolves, it's not something you just turn loose into your manufacturing sites or your company in general. It's something that you have to build competency around. And that's a big challenge for us as well. And we've created a whole organization around Industrie 4.0 between many platforms to help not only find the opportunities out there, but also how to develop the people when the opportunities and the projects go in, that they're able to manage it successfully and that we're able to truly get the value out of what we anticipate. And so these existing facilities are many times the challenges where we have that. So I think we're excited to partner with many universities and excited to be here today too. So thank you.
Thank you. Well, thank you very much. That's fascinating. Now I'd like to turn to the startups, and you're both using vision, one computer vision in two very different ways, one for inspection technologies, Eduardo, and Peter, you in RealTime Robotics, really robot human collaboration, allowing that to happen. So where do you see the next advances going in your mind in terms of computer vision and robotics? We heard, I think you both presented in the initial session, so kind of heard it. The audience has heard about your specific technology, but I'd like to see you think, where's the next step for you? Peter?
Eduardo, do you want to go first?
Yeah, I'm happy to answer. So
Okay.
I think one of the big areas, and this is something that Peter's working on, is how do we take these tools and these technologies and make them more accessible and more useful for a larger number of engineers? I think a lot of this technology that we're dealing with, the startups in this panel, as well as other companies that are presenting here today, we're really looking at technology that might have existed 10, 15, 20 years ago, but nobody was thinking about how do we get every engineer in the world to use these tools? How do we put this next to every factory worker? How do we integrate this into every step of what we're doing as an organization? And I think that that's where entrepreneurs can come in and really step back and say, what are the first principles? What are the things that matter the most? Not what was the thing that was funding this when it was $100 million initiative at maybe a company like Boeing or Lockheed Martin, a huge aerospace company with a massive budget. How do we take this and put it in the hands of a lot of other companies and make it part of the fabric of the manufacturing world, at least in inspection? And that's one of the things we're really excited about in Meter.
Yeah, and I definitely want to focus after we hear from Peter a little bit later on. I've heard it multiple times in the first 10 minutes here that training and is a huge issue. So I really want to dig into that in a little bit, but I appreciate that comment. Peter?
Yeah, I think building on what Eduardo said, it's a getting the technology into people's hands, and I would add economically into people's hands, is critical. We've seen over the last 10 years enormous breakthroughs in vision technology, bringing costs down to an incredibly low level compared to even 5-10 years ago. So cost is coming down. Tools for simplifying the application are coming up. What really is kind of holding things back from much broader proliferation, I would say, is simple economics. In order, there is kind of a tipping point that we have not yet hit in terms of the simplicity of deployment, simplicity of utilization, that until we do, all of the many things that are possible are not necessarily economic. And reaching that point is critical. And it's we're RealTime Robotics as a user and implementer of vision technologies. I would say our core focus is how to bring down those costs across the board in robotic applications in the hopes of achieving that tipping point.
Excellent. And I think I was remiss, as you were not the presenter in the earlier session, of having you introduce yourself. Peter is the CEO of RealTime Robotics, which was presented in the first section with, I believe, Tom Munger presented your company.
Yes, Tom was the presenter for our company.
And how close are you, Peter, do you feel? I mean, I have seen it a lot, to really truly human and robots collaborating. Is that something we think a lot about here? So
yeah, so we're already at a point with the vision technologies that our own people feel comfortable working with robots, but getting to the point where we have the certifications required, where the underlying technology is taken from, say, a safety, a mean time to accident in the thousands of hours to taking that to millions of hours, is where we're focused now, and that's required for any kind of meaningful rollout. Companies like Jaap's would not want to cover our insurance costs if we can't get to that level. So we're working on that. We think we're about 16 to 18 months away, but the progress is very good and quite promising.
yeah, excellent. Check Q&A. Well, my next question, I think you all touched on, but I would like to ask it anyway because I think it's an important one. I think over the last decades, there's been these forecasts. I know Liz Reynolds from our MIT Work of the Future study loves to talk about the sign that says from Prudential on the way into Boston, you know, a robot can't take your job if you're retired. And I think that why that's important is, you know, we've been talking about robots taking all the blue collar jobs for decades. And Peter, you pointed out that only 10% of automotive assembly is done by robots. Now I've seen automotive assembly lines, so I understand kind of why that is, but I'd love to understand why we haven't progressed more. What is it? You know, I've heard economics, I've heard training, I've heard lots of things, and I'd like to hear you all kind of address that.
I'd be happy to, since it's a quote from me, I'd be happy to dive right in. But in the automotive space, if you talk to the manufacturing engineers on those assembly lines, they will tell you that they have had over decades, they've had repeated attempts to robotically automate significant portions of the work done there. And in fact, they're able to reliably get those jobs done. They just can't get them to an economic point that it makes any sense at all. So in many cases, it really is economics. I think where one of the things that plays into the economics is what you were saying earlier, Sheri, about the fact is, I think actually it was Chris who was talking about the ability to, there are activities which a human is just so much better, so much more effective at performing, and you would like to have robots in that same work cell, able to do the things that robots are able to do, but without sufficient speed on the one hand, the speed of an industrial robot with the safety of a collaborative robot. The economics just don't pan out for many operations.
Okay, I'd like to ask you, Jaap, because I think you have a unique industry. Why aren't, I mean, it seems like it should be so easy to do all these inspections without what you call boots on the street, right? It's currently done by engineers going out there, walking around the property. And so what's held you back from really going to be really automating this with robotics and vision?
Yeah, perhaps first to address the blue collar, I've been doing my kid's bathroom. I've been doing all the plumbing in there, and I was like, I'm 6'3", I'm upside down underneath their sink, and we have like 15 different tools. So just imagine that there's going to be a robot doing that. I think you might be in the safest place. If you're just tied to your desk, that's when you have to worry, because it's very easy to tie a robot to a desk. It's not that easy to have a robot crawl into things. Yeah, in terms of the economics, that's definitely true, right? We almost had a similar paradox with just IT in general. If you look at the expenditure between 1980, say in 2015, and you plot that against the increase in productivity, it's hugely disproportional, right? And some of that might be that the IT costs replace some of it, but you don't get the expected increase in productivity just by investing in it. And we might be running into a similar paradox with robotics, where the investments doesn't necessarily give you the ROI initially. But in our case, some of that economics can be circumvented, because if we're looking at confined space entries, there's going to be a point where if a robot can do it, it becomes a safety concern for people. And then it's not so much about the economics, it's just about OSHA restrictions and stuff, and people not doing these kind of things. And we're already seeing that on roofs. We can't get to within 15 feet of the edge of a roof, right? And if you look at a YouTube video of a roof blowing off from a hurricane, it always happens at the edge, because that's where the flashing comes loose and it peels off like a sardine can. So the economics is not so much like, we pay this person per hour this much, and now a robot is, and we put that in a ledger and compare. It's more about, can we even do it? And does the robot allow us now to do things that we otherwise cannot do? So in our case, from the opportunity space for robotics, it's not so much about the economics. The problem is more the heterogeneous nature. I said previously, we insure MIT, and and Disney, right? And what do they have in common that can we have one robot inspect both? Well, you almost need like general intelligence in order to do that, which we're a long ways away from. So that's one challenge. And the other one is just standards and codes. So if you look at the NBIC, which is state mandated inspection of boilers and pressure vessels, they're on a 3-year cycle. And they're just now starting to look a little bit into this, but while that is going on, they still want people to go inside, and get the inspection and all that stuff. And with your comment about boots on the ground, look, we have engineers go and walk by a machine and they smell something funny because these are people that have been doing it for 30 years, right? Or something doesn't sound quite right. So it goes beyond vision. It goes about the total experience that our field engineers have at the client. And again, that is very hard to mimic robotically.
Yeah, I love that analogy about smell and all the senses that we have. Eduardo, it sounds like with your technology, this is actually economically saving significant amount of money, correct? So there's not an economic impediment in my mind from what I know about Meter for actually getting this into the company's hands. Am I correct there?
Yeah.
And so what is the barrier then? If that's not it, what is the barrier?
Yeah, we're certainly lowering that barrier. I wouldn't say it doesn't exist. It's hard to build a business where we sell 3 products without selling something else. But I think to just kind of go back 1 second to some of the comments, I couldn't agree more that I think the real path to getting robotics into industries is really more human augmentation than replacement. I think when you bring a capability that humans are not capable of or extremely bad at, and you do that with a robot or with vision or any other type of sensing technology, smell, sound, whatever that might be, I think that is really the killer place. That's the conversation that we have with many of our partners. How are they inspecting parts today? A lot of them will do it with, people will look at something and that catches a lot of the flaws that are out there, but it can't catch everything. I cannot see through a physical object. Maybe some of you have much better eyes than I do, but I have a hard time seeing through aluminum. And typically that kind of capability has been locked up economically at such an expensive level, like Peter was saying earlier, that it's impossible to even think about it as an option. And so bringing that option and saying, here's an affordable way to do something that's only been possible in the aerospace or the medical implant industry, it totally changes the way people think about the problem. So Sheri, I think the real answer to your question is, if we can really take cost out of the equation and make it very affordable on a per part basis, it's education. It's how do you get people to think about this problem in a different way? How do you show them the capability? How do you talk to insurance companies and show them that, hey, this client now has much better understanding of everything they're producing, so the associated insurance with this activity should be much lower. It flows into a lot of the different stakeholders, and that's why we're so focused on building software tools along with kind of the physical hardware, because the way you access the data, the way you interact with it, share it with other people, use it inside and outside your organization, that is really, I think, going to be the killer way that we get this technology in the hands of many more companies than it's in today.
That's excellent. I want to direct a question to Chris now that keeps coming up, and I think the MIT Work of the Future study, they revealed that, actually robots, much to Eduardo's point, that it's going to be human augmentation, not replacement. And one of the outcomes of this study was there's going to be more jobs and better jobs. And this brings up the issue of training and, your current employees accepting the new technology and not being afraid it's going to take their job. I love the optimism, by the way, from Work of the Future. But Chris, from your perspective, working in Michelin down at right in proximity to their Spartanburg plant, just curious to what you think of what your insights are on that topic about employees and training and augmenting workers.
Yeah, so I think, a lot of companies that are trying to make transformations like this, and, robotics have been around forever, but, like Peter said, the technology's evolved so vastly in the last 5 or 10 years the competency to maintain a robot that now has vision and AI systems and on-edge computing devices, the competency needed to manage those systems is so much more. And so we have a lot of traditional robotics experience at our sites, but developing those competencies not only centrally but at a site level is key to the success, and not only to the success of the project, but even initiating the project. There's lots of projects that I work on, such as autonomous vehicles inside of our sites, that the goal is not to do this project and develop it each time, right? It's to develop it one time and just to add vehicles to the system. And so how have I done that? Well, I've trained my entire site how to manage the navigation system and optimize their flow based on that. And so really the change starts with people, and then the value is how do we add automation to augment their work or create additional value. So what we've done here is we have a whole Industry 4.0 online academy that we give to all our employees, not only in manufacturing, but over the entire company. And so we're starting there, and along with our strong culture of safety, we're making sure that the things we're doing are aligned with our core values, and one of those is respect for people. And so I think that's something we've known for a long time, and it's a challenge that we'll continue to face as we try to automate things that, again, the most complex tool at our site is our people and the experience they possess over 40 years of dealing with our products.
Excellent. I'm going to stick with you since we're almost out of time. I'm going to be asked for a couple minutes from the organizers so we can finish with what I think is a very important question. So I'm going to start with you, Chris, and go through and this is about collaborating with startups, because we know big industry and startups, this is a challenge, right? Different cultures, different. So give us your insight on, how you work with startups and what works best for you in your mind. And then I want Jaap to answer that, and then we'll ask the startups, just to be clear how we're going to end. We'll ask the startups to say what they look for in industry partners, because that's what we're about here at Startup Exchange, is helping you guys connect. So it's good advice for us. Go ahead, Chris.
Yeah, at Michelin, we're big on partnerships, not only with external companies, but with universities, and developing, these opportunities and creating value for the company. So part of what we're looking for there is a strong culture alignment. Again, one of our core values, like I just said, was respect for people. Again, when I look at startups that mention safety and how they're developing new collaborative robots that incorporate safety rated systems into that's a big thing for us as a company, because we have a strong culture integrated into that. And sometimes the automation bears the burden of doing more than even what we're doing today. And so, making sure that we are going back to the facts and understanding that these things are safe, and even more safe than what we have today. So that, along with understanding a history of legacy systems, and being able to not only work with us on the opportunity, but help train our people to understand how the technology works, is just as important as the opportunity itself.
Excellent. Thank you. Jaap, do you have comments? I know you work a lot with startups, even here at MIT. So. Yeah,
in fact, I got to say, that's got to be one of my favorite parts of my job. I was just having a conversation yesterday about what's been the worst part about COVID, because I was able to do my work pretty well in meetings and all that, like everyone else. But it's really that in-person interaction. And my favorite interaction is with the startups. You talked about the research campus. I like to invite them over to our facilities. And we've worked very closely together. We have put an investment in Airworks, which was spun out of MIT. We run a small project with Hosta Labs. And Henriette is on this call, and her and Rachel are doing a fantastic job with that company. And prescient devices that came through MIT, we've done an experiment. So I like, for us, it's very strategic, similar to Chris. Like, we're not trying to be angel investors and hope to become billionaires, how to find a unicorn and all that. It's really getting access to the talent and getting some of these technologies that are coming out of wherever it comes out of, seeing it become an embodiment, and then see if that embodiment can find a place in the market. So, and it's just an experiment that's almost impossible to do in-house. We don't have the talent. We can't keep up, right? No one works as hard as these, working like your life depends on it. That's for an entrepreneur. That's really
well, it kind of does, right?
Yeah. So
livelihood does.
Whenever I go to MIT, whatever is Text 25, whatever the interaction is, I always walk out with a pep in my step. It's always, a little bit quicker and a little bit more ideas. And yeah, I love it. And what I try to do with startups is try to start quickly, have a project that they can work on, have them, even if it's not an investment, have them generate a little bit of revenue, create those partnerships, and let them know that you're serious about about how you value these partnerships.
That's what we're looking to do here. We're not so much trying to get investments for a lot of the startups are well funded. We're just trying to get that first key partnership that helps them become economically viable. I would love to ask you guys, but I'm going to ask the startups. I want to give them the last say about how you prioritize with all these startups swimming around you, but we don't have time for that. So I'll go to Eduardo and Peter, whoever wants to jump in and say, what are you looking for in a company? What makes it work?
Yeah, I'll jump in here. I think the real test that I use to think about whether or not I want to engage with a company right now is, honestly, how big of a problem do they have that we can solve? So, the more of an immediate issue that the company has that I'm able to come in and provide real value around solving that pain point, the more interested I am in diving in with them. It doesn't matter if they're a big logo that everybody's heard of, or if they're a small, medium business. It doesn't really matter to me what size the company is. I want to find the places where there's kind of the most acute pain point, where we're able to provide the largest amount of value very quickly, because those are going to be the people that are going to be very engaged. They're going to be following up. They're going to be complaining about things. They're going to give you really, really useful feedback. Whereas, in other startups that I worked at and Meter as well, we've had engagement with some companies where, yeah, they're a great logo. They're a great company that I'd love to work with someday, but it's 5 meetings and there's no real movement. And, that's really not the sort of thing that is valuable for a startup. We live and die by that feedback and that learning process happening as quickly as possible. So yeah, just the speed of that interaction and getting to the point where there's real work happening. That's the thing that I look for when it comes to working with corporate partners. Excellent. And Peter, you get to end our session.
Yeah, I would simply double down on what Eduardo just said. He's spot on. The lifeblood of a young company like ours and his is getting feedback quickly, testing solutions, testing ideas as rapidly as possible, getting the feedback as rapidly as possible, making it better. And corporate cultures vary. Most of our partners actually are older industrial companies. And among them, there are those who have really structured to deal with young companies like ours, and they're very effective at doing the quick turn, do a minimally viable product together, get that out to some people, get feedback, make it better, cycle through. And there are others that want to have it perfect before they will be associated with it, and those are deadly.
They don't use the 80-20 rule, huh?
That's correct. And there are corporate cultures, even within large corporations. There can be many different cultures, and you really need to make sure, if you are, your sponsors need to make sure that they're to the degree possible, connecting you with parts of the organization that kind of get the need to move quickly, to iterate quickly.
Well, and I've got to end here because I see people flashing in. I think it was a great discussion. I want to thank you all for participating. Peter, I saw in the Q&A a question directly for RealTime Robotics. So by Spencer Powers, I encourage you to go to the breakout session. But anyway, thank you all and enjoy the rest of the conference today.
Hi everyone, my name is Henriette Fleischmann. I'm co-founder and CEO of Hosta Labs. My co-founder Rachel Villalon used to be an architect, and as an architect, she manually assessed building structures, a tedious and error-prone process. She thought there must be a better way. So she applied for a master's and PhD at MIT in computational architecture, by the way, a program that only accepts 2 applicants per year. And Rachel and I met at MIT, where I was about to wrap up my MBA. Prior to that, I worked for 12 years in different management and consulting positions. Together, we founded Hosta Labs. Hosta Labs provides a fully digital and objective structural assessment of the built environment without any special sensors. Assessing spaces is a huge challenge across various industries. It takes millions of humans per year. It involves heavy traveling. It's expensive, it's timely, and as I mentioned, the outcome is prone to error. Hosta Labs has the solution. You take as little as 1 image. You can take many images, and we convert those images into measurements, material takeoffs, and object data, providing insights on risks, on replacement values, conditions. We don't require an app or any special sensors. We use purely computer vision to convert images into bill of materials. And we provide contextual information. So this wall is not just a wall. It's a 6-inch partition wall you see in the background. That is painted gypsum and has 145.5 square footage. Additionally, we convert those images into floor plans and CAD models with high fidelity insights. Like this kitchen you can see here, a trim, we represent the windows of the actual room and further informations that we provide you in several drawings. All of that without special sensors. We are 80% faster than existing solutions in the market. We help you to reduce the assessment cost by more than 70%. And we provide an objective scope of work. If you want a plug-and-play solution to assess your buildings fully digitally, efficiently, and objectively, get in touch at hfleischmann@hostalabs.com. We are currently working with insurance carriers and home improvement companies to provide accurate replacement values, risk insights, estimates, and accurate representations of their customers' homes or industrial sites. We have explored industrial seconds and won a couple of awards for mapping robots, layouts, and risks with our patent-pending computer vision AI system. We are looking forward to talking with you. Our contact is hfleischmann@hostalabs.com. Looking forward to seeing you in our breakout session later.
Henriette, thanks so much. A quick question for you. Besides speed and other things that you touched on, how else would you describe that your technology is unique?
Well, besides being sensorless, which means we literally only require images or videos, it's the contextual understanding of the space. It's a human-like, it's an expert-like understanding we can provide from just an image of the space. So we are equivalent ultimately to a human inspector or adjuster. We're starting out on the residential side and expanding to the industrial settings. If you want to work with us, highly repetitive industrial settings like warehouses, certain plants, etc., are favorable just because computer vision or AI works best on repetitive structures.
Perfect, thank you. Now we will go on to Leela. Cyrus, go ahead.
Hi, everybody. My name is Cyrus Shaoul, and I am here today to tell you about Leela AI. Our company is founded by 3 people who all graduated from MIT, some from the AI lab, some from laboratory computer science, And I was at the Media Lab for a while too. And we've invented a new kind of video insight system that we think can really be beneficial to manufacturers because we have causal modeling AI. It's a patent pending technology that we've invented. And it's very different from a lot of other AI solutions out there. When we started this, we saw there was a pain point out there, and that is that there's a lot of video. 1 billion cameras installed globally by the end of this year. The problem we found is that all the video understanding software, all the machine vision software that we saw really didn't have a deep understanding of what they saw. That is an understanding of cause and effect, which really comes down to common sense. So we built a system which builds its own models of the world from video, from input, from hints from people. So humans are in the loop during the learning, and also can use simulations to learn from. And then it can use this causal model to predict what's going to happen next based on what it's learned. And based on those predictions, it can even use natural language output to say stuff like, hey, someone's standing in a dangerous place, or there were 12 times today when work was delayed by missing parts. So these kinds of situations, we think manufacturing, because people are still involved with manufacturing, as we've heard already today. Human beings aren't getting out of the manufacturing business for a long time. And so we need a system that can understand people, relationship to machines, relationship to robots. And we use in our system existing hardware to do that. I'll explain that in a second. So more than simple detection, has to be flexible and reliable too. It has to be accurate, but it has to also iterate quickly and learn. And so we need something that's intuitive and easy to use. And our system is really, we think, user-friendly machine vision to let people use the system and teach it new things quickly. How does it work? Well, we have a cloud-based engine that is processing video feeds from the customer site. We accept both raw video and compressed video, but also pre-processed video. So if you have a camera that's already looking at, let's say, body position or pose, we can take that data too, and that reduces some of the network traffic. And then the key thing here is that we have a concept store where you can pick concepts that are already there. We have some concepts coming out that are going to be very useful for manufacturing, like are people falling? Are people moving through the safe locations and other things like that? And then you can create your own concepts and put them in your own concept store. And then you can have our system send alerts and also reports about these activities to be used in many different ways. Now here's a quick demo. I don't have time for the full demo, so come to our breakout room to see this video in more detail. But just to quickly say that, this is a demonstration of how a person could quickly define within, probably 5 minutes, a new kind of understanding of a safety issue at this construction site. This is one of our pilots. A person is under a load. That's a dangerous thing. That didn't come pre-built, but someone could add that within 5 minutes with 1 or 2 example videos. So it's much faster than traditional neural network-based machine learning for vision. So what's our focus right now? We're seeing use cases in safety, detecting unsafe and maybe some marginally safe practices, operations, finding bottlenecks, improving compliance, and training. If our system sees what it knows to be the correct way of doing something, but it sees people doing it in slightly different ways, you can take that video and then use it for training purposes. So it's a real great tool to improve training on the job. Right now we're doing pilots in construction. We're doing some pilots in commercial real estate, and we're also doing some pilots in healthcare. So we're trying lots of different things, but I really would love to find a partner in the manufacturing world to work with to show how this tool, which can quickly and very accurately learn new kinds of behaviors to understand, can be used for manufacturing situations, particularly if there's high stakes, people and machines working together. And also, there are some perhaps regulatory situations where you must explain your decision. So we hope to meet people in many industries. Some of these are here, but others we're welcome to anybody. And we'd love to partner with you. Please come to our breakout room. I can show you more, or send me email. Thank you very much for your time.
Thank you, Cyrus. Great. What would you say is a highlight of your technology, the uniqueness of your technology as well? I think that's important.
Yeah, let me just reinforce that. First thing is that our system builds causal models so it can understand cause and effect, which is very different from understanding correlations. So like, for example, if this heavy thing is placed in this location, it might roll down and fall on somebody. So that's kind of causal modeling that a lot of other systems don't do. Second is it's really easy to quickly train and iterate. So you can have someone look at a video stream and say, oh, I see this is the behavior I want to train Leela on. And within a few minutes with a couple of videos, they can create this new concept that can instantly be used, tested, iterated, and then improved. So there's that kind of really nice user-friendly non-programmer, no coding needed type of interface to improve the machine vision system. And most of machine vision systems do not offer that kind of flexibility. So we think that's a real big benefit of our system.
It's a big plus. Thank you, Cyrus.
Thank
now
you.
we'll have Pauline from Farmwise.
So I work in strategy at Farmwise. I joined the company right at the beginning. We were founded by Sébastien Boyer, who graduated from MIT in 2016. Pretty young folks. So at Farmwise, we're in business to help farmers deal with the new farming era. So today, the cost of agricultural production are going up to the roof. A lot of processes that are done on the farm are done by hand, using a lot of hand labor. We're also very chemical reliant. And at the same time, we're facing challenges such as increase in, the need to increase food production and dealing with external factors, a planet that's warming up and that's doing a lot of different things to the environment, and that makes our condition to farm challenging. Our solution to that is to empower farmers with data-driven services to bridge the gap and be able to generate the food that they need to generate and in a sustainable way, both from an economic and an environmental perspective. So this is our very first product. This Titan, it's a self-propelled autonomous robot that detects crops from weed using computer vision, and that removes weeds on the field using robotic arms. And so essentially, Titan works on green vegetable farms. We work on all kinds of crop from lettuce to cauliflower, broccoli. And these machines go through the field and essentially help farmers replace jobs that used to be done by teams of 25 people-ish on the field. And so we're definitely using all kinds of cameras, sensors, and lighting shades in order to understand what's happening at the crop level. So compared to previous decisions on the farms that were very field level based and very visual cues based, we're actually looking at what's going on the bed. How are the lettuce plants looking from one another, and what's a crop, what's a weed? And so we're training essentially detection model to do this plant species detection. And we're also training those models to understand where the center of each crop is located so that we can then calibrate tools that open and closes around the crop and clean the field. Today this, I would say this sequence of technology, so computer vision, robotics, and then hardware. So all the design, all the enclosed systems that are designed to support those technologies reflect essentially the way our team is built. So we have a whole bunch of robotic software engineer, computer vision team, and then hardware engineers, mechanical, electrical. Titan is not sold to the farmers, which is quite contrary to what's traditionally happening in the market. Farmers love to own equipment for a lot of various reasons. Love for the brand, first of all. We are today offering our product as a service, and the reason for that is we're a young company, we're 4 years old. Our technology is mature, but needs to be refined. And we're seeing a lot of value in putting the product today in the hands of the farmers while collecting a lot of data that is necessary for us to improve, to get better at what we do. And so we are the third design iteration and working on a fourth generation right now that is probably meant to be sold. We are operating in California along the Central Coast, where something like half of the vegetable production of the United States is happening. And also in Arizona, it's the winter season down there. And we've deployed about a dozen robots. We're currently actually actively working, the season has just started. So we have a dozen of customers for which we do recurrently work every week throughout the entire year. Little case study for you to better understand the people we work with. We work with extremely large farms. So actually the vegetable production in America is very consolidated. So yes, at the farmer's market, you're probably dealing with small scale farms. The people who provide the Walmarts and the Whole Foods in the world are extremely large operations. And for these people, we do two types of services. We obviously weed their fields. And then we're also providing them access to their data. So we came to realize that the information that we collect in order to the job that we do on the field, so understanding the size of the plants, the number of plants, the location of the bed, the GPS coordinate of the plants relative to other plants on the bed, all of this has value for our farmers. So we're essentially giving this data back, repackaging this data back to the farmers to help them make key decisions on the farm, such as yield prediction. And so Bonipac is one of our customer. You may recognize the label. In terms of partnership, so as I just said, we are barely scratching the surface of the potential of the data that we collect. We think that down the line, there's potential interest for our data downstream and upstream, from input companies to retailers. We also think we will be doing more on the data side, aggregating external sources of data. So I'm very interested in having those kind of conversation and see how we can build kind of a plant level farming database, the first one of its kind. And yeah, I'm happy to chat during the breakout rooms. You have my email, please reach out. We're always happy to share about our work. Thank you.
Thanks so much, Pauline. Very interesting. A question for you. What's one of the main things that you look for when working with a corporate?
Very good question. We are a very young team. We have very young founders, first-time entrepreneurs. So we're always looking for experience and I would say strategic guidance in the big decisions that we take. So we're very interested in having some kind of like advisory relationship, I would say. And we are actually building actively an advisory board and working with people across the board. We're also obviously interested in product partnerships, so thinking about strategic partnership creation. We are, exploring things with chemical companies around. So if we have this capacity to understand what's going on at the plant level, how about shifting the way we spray pesticides on crop down to exactly what the plant needs? So having those kind of like conversation is very helpful for just strategic orientation for the company as a whole.
And now we're going to move to Victor from OnSpecta. Please go ahead.
Hi, my name is Victor Jakubiuk, and I'm the co-founder and the CTO of OnSpecta. At OnSpecta, we make the software layer that enables your AI applications to run faster across heterogeneous hardware, across CPUs, GPUs, and custom AI chips. What that means for you is you can get 10x speed up for your computer vision applications, for your robotics applications, and for your industrial automation applications. All of this is done in software. The company and the research came out of my original research at MIT at CSAIL, and that's how we got started. The problem we're solving is the AI deployment problem. Today, if you look at your R&D lab across machine learning engineers, deep learning engineers, they all come up with interesting deep learning models that solve your business problems, that automate your processes, that fix your computer vision problems. But the problem is a lot of those models don't make it from the R&D lab to production. And the reason for that is that AI models are very sensitive to their production environment. For one thing, you have to ensure that the data that you're using in production is exactly the same as the type of data that you use for training. Then you have to decide where to deploy, whether it's in the public cloud, in your private data center, on the edge, and embedded devices. Depending where you deploy, you have to use different hardware. And what that means, you have to use different software stacks. And those software stacks are not only slow, but they're also not compatible with each other. Oftentimes, when you deploy the model for the first time, you realize that it's not good enough, it's too slow, it's not accurate enough. And oftentimes you have to go back to the drawing board, start with a new model, retrain the model, and start the whole process again. At OnSpecta, we're solving those problems. Our core product, the deep learning inference engine, enables you to deploy your AI applications across all sorts of different hardware, CPUs, GPUs, custom AI chips, on the cloud, on the edge, and anywhere in between. We give you a lot of speed up. We give you up to 10x speed up, meaning 10x lower latency, 10x higher throughput, or 10x lower cost. And on top of that, we get you memory compression. Beyond the core inference engine, we also have two other products. One is to help. One helps you select the best model for the problem you're trying to solve, and the other one, DLOps, helps you with monitoring and analytics of your actual deployment. So let me tell you a little bit about one of our customer use cases. We work with a large US-based smart camera company. Due to COVID, they needed to recognize people with and without masks as they enter the office. They needed to run their computer vision applications both in a public cloud and a private data center, as well as directly on the cameras themselves. And depending on the customer, they needed to pick different type of deployment. We have provided them with a software layer that enabled them to run the exact same model across all those different modalities, providing them with a uniform user experience, regardless if things were running on the camera or on the cloud. The end result for them was that on the cloud, they saved money. And with edge and with embedded devices, with those cameras, they didn't need to invest into more hardware to run their AI applications. OnSpecta is a horizontal AI software solution. We're not specific to any particular vertical. We're looking to work with the companies in semiconductor space, with the autonomous driving and robotics companies, in manufacturing, as well as industrial automation. We're looking for customer opportunities as well as partnerships. We would like to talk to the CTO, the head of AI or machine learning, or the head of digital transformation at your company. If you would like to learn more, please join me after the session in the breakout room, or send me an email to victor@onspecta.com. Thank you.
Thanks a lot, Victor. That's great. A quick question for you. How does your deployment actually work?
It's a very seamless deployment. In fact, you can deploy our software along with your standard AI frameworks. So there are no changes to the APIs. There's no need to recompile your models. Everything works out of the box. Whether you deploy our software with, whether you deploy TensorFlow or any other AI framework with or without our software, it works in the exact same way. With an exception that with our software, you get to deploy this across all sorts of different hardware, and you get the speed up, meaning cost reduction in the data center, and you can run bigger, faster models on the edge and embedded devices.
Thank you. So thanks, Victor. Thank you to all the speakers, and thank you to all of you for joining us, wherever you might be today. And now for the ILP members, please join us in the breakout rooms with the 8 startups. I have put the link for the Zoom meeting in the chat. Thank you again, everybody. Ciao.